All right, so now we are going to build our cap configuration on NIRSite Montage software. So when you initially open the app, it's going to have this select head model window pop up, and you will select the adult if you're working with a population that's above 8 months. Any population under 8 months, you're going to use the infant head, and the reason for this is there's going to be a different cap layout needed for a infant head, and the distance between the sources and detectors will be shorter. In infants, they'll only be about 2.5 centimeters, and they'll be around 3 centimeters for children and adults. So the differences between sources and detectors, the optodes. So I'm going to click OK. When you initially open it, it's going to default to a 3D model of the head, but it is very important that when you're building your configuration on your site that we use the 2D version. And the reason for this is the 3D model allows you to place an optode wherever you want. The 2D model forces you to choose a cap layout, and it allows you to choose a layout that matches your physical cap. And like I said, depending on the age of the participant, the cap layout will be different. For example, the 1010 layout will be used for infants. And so the 1010 layout will look like this. There's less slits in the cap and they're more spread apart. And then the 10.5 layout has a lot more spaces for optodes to be placed. So the 10.5 layout is what is used for 4 and 5-year-olds, for the subjects that we work with, as well as adults. So I am going to use the 10.5 layout for this cap configuration. So now we are at the point we are going to use our text file as a guide to build our cap configuration in NIRSite. So this text file is nice because it gives you all of the information from Fold. It tells you what atlas you used. We used Brodmann's area. The coverage specificity was 40%. We have the amount of sources and detectors. We have 7 detectors, 8 sources, which fits in our 8x8 range because that's the fibers that we have. And it tells us how many channels that would make. So that would make 18 channels. And then it tells us what landmarks we use. So we use 9, 10, and 46. And then the most important part for building our configuration in NIRSite, it tells us where we should place our sources and where we should place our detectors. And on top of this, if you scroll down, it tells you what regions each source and each detector is covering based on the anatomical regions of interest that you chose. So for example, the first one would be the dorsolateral prefrontal cortex. So, and it tells you how much it's covering that area. So this is something that you can save, but I'm going to focus again on the sources and detectors in this text file. So we want our first source we'll put on AF3. So I'm going to come back to NIRSite. So when we're doing NIRSite, to plot your sources and detectors, you need to hold down Shift, and 1 click is a source, and holding down Shift and 2 clicks is a detector. And so it will number the sources detectors in the order that you click. So we're going to put our first source on our 10.5 layout. So we said we wanted our first source on an AF3, so I'm going to click Shift and press AF3 once. Okay, so our next source will be on AF4, so it's the same spot on the right side of the head because we are making a symmetric configuration. The sources and detectors will be numbered in the order that you click. Since they will be numbered in the order that you click, it is important to think about how the fibers themselves are organized. The fNIRS fibers are bundled into groups of the 4 sources of detectors. So S1 and S2 are bundled together. So if you're going to place source 1 on one side of the head and source 2 on the other side of the head, this might make it difficult to keep your fibers uniform, untangled, and smooth. So sometimes it's nice as you're building your NIRSite montage is to think about how your fibers are bundled and where you want to place the sources and detectors so that they lay nice on the head and they aren't getting tangled with each other. Since source 1 and source 2 are bundled, I don't want to put this source 2 all the way on the other side of the head, so I might put source 2 on AF7 since it's closer to source 1. So what I'm going to do is, since I made a mistake, if I hold shift and click 3 times, it will turn green. This is sometimes used for like a dummy optode to kind of like orient yourself, but this won't track as a source or a detector. So I changed my mind. So since they're bundled together, I'm going to relabel and put my second source on AF7 because that's one of the places a source will go. So I'm going to go to AF7 and click once. So same thing with the detectors. Source detector 1 and detector 2 and our fibers are bundled with source 1 and source 2. So I'm going to make sure I put the detector 1 and detector 2 close by source 1 and source 2. So I am going to put it looks like we have F5 as one of our detectors. So I'm going to put detector 1 on F5. So again, I'm going to hold down shift and click twice. So since I placed my first detector, you can see here that there is this purple line that comes from each of the source and goes to the detector. What this means is all the sources are emitting light to the through the scalp into the brain. So this is, fNIRS is an optic neuroimaging technique. So the light will emit from the sources and detectors will receive the information from the light. So each detector can receive information from up to 3 sources. So as I plot more sources and detectors, what's really nice about NIRSite, it will automatically tell me what sources the detectors are receiving information from. Okay, so now I'm going to plot my second detector. So again, I want to, because it's in the bundle of my fibers, I want my second detector to be near this group. Let's put it at F1. So I'm going to hold down shift and click twice. As you can see, there isn't any channel being formed here, and one of the reasons is the distance between this source and this detector might be too far, so they have to be around 3 centimeters apart. So I'm going to put another source at F3, and then you can see, because the distance is around 3 centimeters, the channel will automatically form. So I'm going to go ahead and build the rest of my configuration. Okay, so I have built and created the montage that we use for one of our studies. And so this is what our finished montage looks like. So in this case, we wanted a few parietal areas. So when we used fill, these are the locations that we decided to place our optodes. So I want to now show you what you can do to upload it to the data acquisition software Aurora. So we have used the 2 softwares that we needed to create our montage. The next step is making sure that our acquisition software Aurora has this uploaded. So you can do a couple of things. You could save and make a montage name and export it directly to Aurora, or you can save it in your documents and then from Aurora, upload your montage. So for the purposes of this video, we're just going to save it in my documents, and I'm just going to call it test. And we will make another video to teach you how to grab your configuration from Aurora if you saved it in your documents or if you downloaded it or uploaded it directly from NIRSite to Aurora acquisition software.